Section 5.2, direct variation part 2. We're going to do some word problems and some graphing. Okay, so the first one, weight on Mars y, so this is your y, varies directly with the weight on Earth, which is your x. The weights of the science instruments on board the Phoenix Mars lander on the Earth and Mars are shown. Okay, so they're saying that if their weight weighed 130 pounds on Earth, once they got to Mars, it only weighed 50 pounds. What is an equation that relates the weight in pounds on Earth and weight on Mars? Okay, so we're starting, they already told us it does vary directly. Okay, so we know we're using this y equals kx. We're going to plug in what we know, which is that our y is our weight on Mars, and that's 50. We don't know the constant of variation yet, but we do know that x, or weight on Earth, is 130. Okay, so to get our equation, we need to get that k by itself. Divide by 130. Okay, and we find out that our constant of variation is 0.38, which gives us an equation that is y equals 0.38x. Okay, so when they ask with what is the equation that relates these two, this is our equation. Okay, then they're going to ask us to use that and graph this, right? So I'm going to transfer that over here. Y equals 0.38x was our function. Now we're going to pick our own numbers to plug in for x. X was weights on Earth, so it doesn't really make sense to have any negative numbers. So I'm going to start with a 0, and then I'm going to plug in a 50, a 100, and a 150. Okay, just for nice round numbers. You could have put whatever you wanted in the x, but now I'm going to use this equation at the top to solve for my y. So 0.38 times 0 just gives me another 0. 0.38 times 50 gives me 19. 0.38 times 100 gives me 38. And 0.38 times 150 gives me 57. Now I'm going to graph these points as ordered pairs. My first ordered pair is at 0, 0. My second ordered pair is over 50 up 19. Then over 100 up 38. Over 150 up 57. Okay, and if you notice, all of our characteristics of a direct variation graph are shown here. Passes through the point 0, 0, makes a straight line. It is not a direct variation if it doesn't pass through 0, 0. Okay, here's another one, similar situation. Weight on the moon, which is your y, varies directly with the weight on Earth, which is your x. What is an equation that relates to them? Okay, so we have y equals kx, but I happen to know that 16.6 is my y, and 100 is my x. Okay, so I'm going to divide by 0 to get, or by 100 to get that k by itself. And I find out that 0.166 is my constant of variation, leaving me with the equation y equals 0.166 times x. All right, so this answers the first question, what is the equation? Then they want us to graph this. Okay, so much like the last one, we're going to pick weights on Earth, so we don't need anything less than 0. So I'm going to say 0. We'll just use the same numbers, 50, 100, 150. You can even go up to 200 if we'd like. All right, so if I plug in 0 times 0.166, I get another 0. 50 times 0.166 is 8.3. 100 times 0.166 gets me 16.6. This is 24.9. And then here we have 33.2. All right, we're going to use those as ordered pairs again, and we're going to graph back here. We start at 0, 0. Over 50 up 8.3. Over 100 up 16.6. Oh, I missed it over here. Over 150 up 24.9. over 200 up 33.2. Okay, all of our qualifications have been met. Goes through the point 0, 0 and makes a straight line. Perfect. All right, last one of these. Suppose 15 US dollars is worth about 150 Mexican pesos. What is an equation that relates the US dollars to the Mexican pesos? All right, so we know it's a direct variation. We're going to plug in what we know. So we have 150 equals K times 15. Divide that by 15. Find out that our constant of variation is 10. So our equation is y equals 10x. All right, we don't need any negatives on this one either because we can't have negative US dollars. So we're going to start with 0, 10, 20, 30, whatever you want to do. But when I plug this in, 0 times 10 is 0, 10 times 10 is 100, 10 times 20 is 200, and 10 times 30 is 300. Okay, so when we make our graph, over 0, up 0, maybe we should fill these numbers in first, huh? I'm going to go like this. This is a 0, this is a 10, 20, 30. 100, 200, 300. Okay, we'll put our dots in. That is 0, 0, over 10 up 100, over 20 up 200, over 30 up 300. All criteria is met. Our graph has a straight line that goes through 0, 0. That is a direct variation. All right. On your direct variation graphs, it's very easy to tell which ones are and which ones are not because they have to be straight and they have to go through 0, 0. If they don't have either one of those, they are not a direct variation. Okay, they can be positive, they can be negative. This one is a positive because it's going up. This is a negative because it's going down. They are both direct variation graphs. All right, so now they want you to be able to write the direct variation from the table. So we have to figure out if it varies directly, and then if it does, what is the equation? Okay, so the best way to figure out if they directly vary, remember that our k, our constant of variation, we found by dividing y by x. Okay, so that's what we're going to do here. We're going to say 6 divided by 4. We know that gives us 3 over 2. Then we're going to try 12 divided by 8, which also gives us 3 over 2. And then we're going to try the last one. 15 divided by 10 also gives us 3 over 2. If these are all the same, this is a direct variation. Our k is 3 over 2, and then we write our equation as y equals 3 over 2x. So this one was a yes, and that's our equation. Okay, letter B. Start with this one. 3.2 over negative 2, 2.4 over 1, and 1.6 over 4. Well, I know that 2.4 over 1 gives me 2.4, and that 1.6 divided by 4 does not give me 2.4. So these are already not the same, so this is just no, not a constant of variation, not a direct variation. All right, we're going to try these last two, and then that'll be it for today. Okay, first one, 5 over 2. Then we have 15 over 6 and 25 over 10. Okay, well, 5 divided by 2 is 2.5. 15 divided by 6, if I simplified it, divided them both by 3, I would get 5 over 2, which is exactly the same as 2.5. And 25 divided by 10 is also 2.5. So since these are all the same, This is a yes. And my constant of variation, we want to write it as like a slope, a rise over run. So it's going to be y is equal to 5 over 2x. Okay, and last but not least, we have 7 over 1, 10 over 3. But already I can see 7 over 1 is 7. 10 divided by 3 is 3.3 repeating. So these are already not the same. So this is not a direct variation. All right, you should be able to finish your assignment today, which means all you have left is on page 302, numbers 21 through 24, 27 through 29, and the rest of your lesson quiz.